Hi everybody, I'm Gerald, this is my best friend, and we're going to start a discussion on kinematics. Hi everybody, welcome to the shop. Like I said before, we're going to be talking about kinematics today, which is beginning the study of motion. That's what we're talking about. So initially, we're not going to be looking at any motion that's crazy or anything like that. The motion we're going to start with is going to be motion that looks more like this. In order to start, we first have to agree on the terms. So the terms I'm going to focus on in this video, which I'm going to try to keep rather short, are going to be simply position and distance. What's the difference between the two? Also note, for the next bunch of these videos, all we're going to be talking about is motion in a straight line. So the things that we're talking about is motion that's just going to be back and forth, or this way and this way, or this way and this way, but nothing odd like that little rocket that you saw shoot off before, okay? Now eventually we'll get into two-dimensional motion, but that's not for a little bit. We have to really develop all the terms. Okay, so what I want everybody to look at here are I basically have two number lines, number line L and number line M. And I've got 2 points, and if you notice they're in the same position, sort of. The number line L has a different labeling than the number line M does. So if you were an observer on line L, that's the line you were looking at and you weren't looking at line M, you would say that H, the point there, has a position of 3. Whereas basically the same point, I have it labeled red, I have it colored red rather, and labeled G. That would be at position 0. And I can move these points around. So now, I would say now H is at 4, H has a coordinate of 4, and G has a coordinate of 1. If I move them all the way over here, just depends on the number line that you're on, I'd say H has a coordinate of 12, and G has a coordinate of 9. And I can move these all day around. And there's nothing wrong, by the way, with fractional coordinates. Like that looks to me like G would have a coordinate of 1.5, and H would have a coordinate of 4.5. And if I move these back, negatives are no different. This looks like G, the coordinate. Let's move it over a little bit, actually. G, I would say maybe that's like negative 2.75. Whereas with H, that would have a coordinate of 0.25. And we can make them both negative, maybe that H looks like it has a coordinate of negative 0.5, and G looks like it has a coordinate of about 3.5. I think it is time to sum this video up. Well, who am I to not listen to Darth Vader's head? So it is time to sum up this video. What did we do? We talked about what kinematics was, the study of motion. The two things that we got out of the way today are when a point is moving, we sort of impose a coordinate system on it. It doesn't matter what the coordinate system is. So we can look at its position at various times, which you'll see in a minute, but basically we define its position by its coordinate on that particular number line, and the distance that's defined to be between 2 points, or maybe like a point at one time and a point at another time. We want to know what that distance is. As long as it's moved in a straight line, we can simply subtract the lesser coordinate from the greater coordinate, and that tells us how far apart it is. We are at the iPad, and let's look at these problems that we got. So first it says this: what's the distance between, let's mark this down, doing this problem right here, what's the distance between A and B? Now, it would be easy enough to count, but let's not do that. Let's use the formulas that we have, the things that we developed. So when the numbers aren't so nice, we can still do these calculations. So the distance between A and B, I think what I said was we're going to calculate this by finding the coordinate of the point on the right, or the greater coordinate, and we're going to subtract the smaller coordinate. So in this case, the coordinate of B would be 2. And the coordinate of A would be negative 3. So we're going to do 2 minus negative 3, which gives us 2 plus 3, which is 5. So the distance between A and B would be 5 units, whatever they are. Now, I said subtract the smaller from the bigger. So the one on the right minus the one on the left. The larger minus the smaller, however you want to say it. But if you do it the other way, you're always safe if you put absolute value bars around it. For example, you could do the coordinate of A, which is -3, minus the coordinate of B, which is 2. And if you took the absolute value of it, you're going to get the absolute value of -5, which is still 5. So you can do that as well. All right. So let's do the next one. So the next one says we want the distance between B and C. So now C is here. So the larger minus the smaller, the coordinate of C is 9, minus the coordinate of B is 2, and we're going to get 7. Now, the distance between A and C. All right, well, the coordinate of C, that's still 9, right there. The coordinate of A hasn't changed, that's -3, so it's going to be 9 minus -3. That's going to be 9 plus 3, which is going to give us 12. Okay, now, let's scroll down to another one where we're sort of going to apply this. So now what I'm looking at is a meter stick. And what I want, the question says, I want the distance between A and B, and I want the answer to be in meters. All right. Now, this is like a picture of a meter stick. Let me blow it up a little bit so you can see it a little bit better. There. Okay. So this right here would be the 10 centimeter mark. This would be the 20 centimeter mark, etc., all the way down the line. So this is sort of like its own number line, right? Where this would be 0. And I guess you could say this is 1. So what does that make the scale? Well, in terms of meters, 10 centimeters, that's a tenth of the way there. So that's going to be 0.1 meters and so on and so forth. So when we look at this, we can say here, what are the coordinates of A? Let's count that out. We're at basically, what is this going to be? 30 centimeters. So remember, the coordinate right there is going to be 0.3. So that's going to be 1, 2, 3, 4, 5, 6, 7, 8. So the coordinate of A is going to be 0.38 meters. By the same argument, here we are for B. The coordinate of B is 0.68 meters. So a lot of times when we're working in physics, I mean, sometimes we definitely put the units in, and I probably should, right? 0.38 meters and 0.68 meters. But a lot of times when we're doing calculations and we know what's going on, we just leave the units until the end. So in this case, we're going to have 0.68 meters minus 0.38 meters, which is going to be equal to 0.30 meters. Okay, so the distance between A and B is essentially 0.3 meters or 30 centimeters. All right. So I hope if this video helps you and you like the content of it, please like and subscribe. Helps me out, and I will see you on the next one.